Hey guys, so today we're going to work on a board. It's a 13-inch MacBook Pro Retina. This is a late 2013. The model number on the board is, where is it at? There it is, 820-3476. And this one had a very interesting issue, and I was going to discuss it with you guys. Maybe we can figure out why this happened. I have a few ideas of why this may have happened, but right now this board has absolutely no power. And I don't know if you can see why. Let's see if I can show you. Where is it at? Oh, can you see that chip right there? See how it's burned completely up? I'll just show you under the microscope, give you a better view. Let's see. Let me get me in focus first, then I'll get you guys in focus. See that beautiful chip right there? Has a hole burned in it. It's a pretty severe burnt chip there. And literally, it has a hole burnt in it. It just crumbled. So this is a badly shorted chip. Now this either had a power surge through it, or it had a quick short to ground and just burnt that chip up completely. So we're going to try and fix this. The thing with when things like this happen to boards, a lot of times what it's going to do is, I guess you could say galvanized. The solder no longer becomes melted. You can't melt it anymore. It becomes like a steel metal. And so when that happens, it permanently bonds to the board or the pads, and when you go to remove it, it's going to take the pads right off the board. So we'll check and see if this is repairable. I've run into a lot of these that aren't. It just happens where with a chip that big, if it burns that bad, it's going to burn through the board as well, and there's multiple layers in this board, and so if it happens like that, you're going to end up damaging a lot of other power lines. So we're going to see. I'm going to go ahead and add some heat to this. I'm going to remove the SSD card first of all, because if we're adding heat to the board, we don't want to damage that SSD card. So pull that off, and then what we're going to do is just add some heat to this chip to see if we can remove it without it damaging the board any further. Let's see if I can get you a view. I changed my desk around a little bit in hopes that we could get a better quality film for you guys. Hopefully that's okay. Alright, so we're just going to add some heat and see if we can remove that chip. I'm just going to remove these capacitors around it too, because they look pretty bad. And I think this side is really stuck to the board. So I'm going to have to do a little bit of prying here. Thankfully that's quite a large pad there. I'll remove that coil. And I see how that pad was stuck, so that came off. Yeah. Alright. Well, see what we can get here. So we see we got a lot of damage to this board right now. Let's go ahead and clean the board up so we can get a better picture of what's going on. So this copper is no longer, you're not really going to be able to solder this anymore. So what I'm going to do is I'm going to go ahead and remove a chip from another board, and we're going to check it out underneath and see how the best way to approach this is going to be. Alright, so I'm going to make sure we got the orientation on this chip memorized. This is the dot here, so we got pin 1 on this side, so I'm going to save it just like that so I don't forget. Alright, now let's compare these two pads. So we have this pad here goes to this coil in this leg. And these three, I think these 4 pads right here are not really damaged. So we have those 4 pads that look okay. I think we can salvage that. We'll be alright. Not sure about this. We're going to probably have to cut that off and run a wire. And then this side we have this one pad, pin 1, that is separate from pins 2, 3, and 4. Alright, so this pad is still here and intact, it looks like. Just 2, 3, and 4 that's been completely damaged. Okay, so what I'm going to do is let's look at the board view real quick so we can get an idea of what these pads do. Maybe we can take some measurements, make sure we have no short to ground on these areas, and just see how to approach it from there. So, sorry, you've been out of focus for a little while. So we're just going to hop on over to the board view. Okay. Alright, so here we have the board view. And here's the chip that we're looking at here. So this is going to have to do with our 3.3 volt rail. And so let's just zoom in here and see what we have. So pin 1 we have, which is not ground, and that's our 3V3S5. So let's just take a measurement. Let's see if I can get a good view of the multimeter here. I'll have to figure out I think I've messed up my display captures on that, so I'll have to fix that for next time. But alright, let's check and see what we have here. Let's check for a short to ground on pin 1 first of all. Alright, so go on the ground, and then we're gonna get this off. Okay, so pin 1 is right here, and let's touch this probe on ground. So what do we have? .419. So we have no short to ground there, so that's good. All right, so the let's see. So the next pads are these right here. The 3 pads over here, and this is PB bus S5 HS other 3v3. So we're gonna that's not ground either. So we're gonna go back over to the microscope, and we're gonna check for a short to ground there to see what our reading is. And what do we have? 0.6383940. Okay, so that's not a short to ground either. So we're looking good there. Alright, and now let's hop on over here and measure these. What is this? 0.6, 0.5. So we're good there as well. I'm on. Alright, Now I'm on resistance mode. Let me hop back over here and just measure these real quick again. I was on the wrong setting. So 1.5. We're good there. This one is 0.129. Let me make sure. Okay, so there we go. We're getting a reading there that's not short to ground. And then these 3 pads here are shorted to ground. Okay, so we have a short to ground on those 3, but we'll have to see what that is. And this pad here is not short to ground. So back over to the board view. These 3 here are, guess what? They're ground. That's why they were giving a ground measurement. Alright, and this one is not short to ground, so that's good. And this one here is P3B3S5LL, okay? So let's check that and see what we get there. And that is the one that goes to the coil. So this reading is also not short to the ground. Hey, looks like we got kind of lucky here. We have no short to ground on this. So it's interesting the reason this happened. Zoom out. Oops. Okay. It's interesting to think about the reason why this possibly happened. The only reason I can think of that I've seen this happen before is we have a non-Apple third-party battery. This could be the whole cause of it. I've seen it happen many times before. Very rarely with the Apple original battery, OEM battery. It happens mainly when it's third-party batteries. And I don't know why, but it has to be something with the power output that they're giving, and maybe some sensors in the battery that's causing it to do this, is my guess anyways. But that's likely the reason this chip was blown up, because this is actually your 3.3 volt rail, and it's coming from your 5 volt rail as well, because there's one chip that outputs both of those. So I don't know why it happened, honestly. This was an easy thing to narrow down because of how badly the chip was damaged. So what we're going to do now is I want to fix these traces, give it something to solder to, and we're going to put the chip replacement chip back on and see if we have a working board. So let's move on forward with that. I'll give it back over to the microscope view. Wrap up a multimeter. Alright, so I'm going to cut some of these traces up and give something for us to solder to. Actually, let's just go ahead and see if solder will take on these pads, because if it does, then that might make our job a lot easier. Alright, let's see if we can add solder to these pads. That took solder okay. The pad there took solder. That took solder okay. Okay, we might be okay. So let's go ahead and try and put the chip on. The chip. It goes like this. And the only concern is it going to reach? It looks like it's going to reach to those pads. So let's just try it. What's the harm in trying? Applying pressure to the chip. Solder out. Okay. And now we're going to get some replacement resistors, or capacitors. So first of all, this little capacitor. There. This one. What I'm going to do is add some flux to the area to make sure we got a good solid joint. And now let's put the replacement coil on. Alright, looks like everything is in place. And is it solid? Check and see. Yeah, it's not moving, so that's good. Nope, that one's not held on very good. Let's put some more flux on that capacitor. That capacitor broke. I need to replace it. In just a moment, I'll be right back. Now let's let it cool down for just a moment, and we will give it a test and see how it works. Green light, orange light. No power going to the fan. Could be two things. These models, some of them, the fan doesn't turn on right away. So it could be that, or it could be that the board's just not powering on. And I don't feel it's hot in that area still because of where I soldered it, but let it cool down for a few more moments. Alright, so we have no power to the board yet. I mean, there's power to the board, but it's not turning on. So let's go back over here to the microscope, and let's use our multimeter to measure some parts of the board and see if we can figure out what's going on. So I'm going to flip it over, and here we're going to first of all just check and see if we have power to our PP bus, and we're going to check out the power here. voltage. Let's see what kind of readings we get here. Put your microscope. Zoom in on the multimeter. So we're getting 0 voltage there and 15.9 volts there. It's an interesting reading. 16.5 as it should be there. Okay, so let's turn it over to resistance mode and see if we have a short to ground on PP bus. No short to ground, no short to ground. So no, we don't have any short to ground. Oh, wait. I wasn't touching good enough there. Alright, so we do have a short to ground on our PP bus. Okay, so the next thing to do is to figure out where the short is going. So let's pull it up on our board view, and we can take a look and see where that that power rail is going to. Alright, so let's go over to the other side of the board. Here we have our PP bus chip, our charger chip. And here is the 2 resistors that I was measuring that had no voltage. I believe that's the 2. Yeah, that's the 2. Alright, so R7152 and R7151. So let's look at the let's see, this is R7100 or U7100. So U7100 is going to be our charger chip, our P-bus supply, and R7151 and R7152 are the 2 chips that we have no power going through because there is a short to ground. Now, let's see here. Why would there be a short to ground on this rail? So there's 2 things that could be going on. It could be on this side of the chip, or on this side of those resistors, which could be the U7100, the P-bus chip, could be short to ground, or it could be the other side. It could be anything on this side of the machine, which goes on to many other different components of the board. So the way to narrow that down and figure out which side it is that has the short to ground on it would be to just remove these 2 resistors and figure out whether it's this chip or anything else. So let's go ahead and remove those 2. Now we're just going to measure one side of the leg there versus the other side. Still on resistance mode. Yep. Alright, let's check. This side, do we have a short to ground? No, we do not. And on this side, do we have a short to ground? Yes, we do. So this is going to be on the other side, which, if we look back at our schematic here, here's the 2 resistors that we removed, R7151 and R7152, these 2. We measured on pin 1 first, there was no short to ground, so the P-bus chip is not short to ground. It's going to be something on this side that is short to ground. So this could be anything from this MOSFET here, or it could be anything else that goes to the rest of the machine. So we have a lot of different possibilities here to look at. So let's see how it goes back up here. Let's find the fuse F7140. Where is that located? So let's do a search on the board view. F7140. Ooh, alright. And that fuse is down here. This fuse right here. So let's see if there's a short to ground on that. F7140. Is there a short to ground? Yes, there is. Alright, so what we're going to do now is we're going to remove this fuse. Okay. Now let's measure on both sides of that. See which side is shorter to ground. This side? Yes. This side? No. Alright, so let's look back over at the board view. So we have this side here. And on our schematics, that is pin 2 of F7140. F7140, we have pin 2, which goes to the entire system. See, this goes to the rest of the system. So everything on the left side over here is not the problem. We've narrowed down that it's not going to be this line that goes up here to this MOSFET, and it's not going to be this down here, the Q7155. This is not short of the ground. However, it is everything else, or anything else, to the rest of the system. So we're going to inject some power. When you have a short to ground, the best thing to do is to inject power with the power supply into that line, and whatever area is going to be short of the ground is going to get hot, because there's going to be a lot of amperage going through that line, a lot of power going from your rail directly to a ground, and so that area is going to get hot. And it's an easy telltale way of saying, hey, this part is what's short of the ground. Remove it, replace it, and we should be good to go. So let's go ahead and solder in some wires to the board. We're going to solder in the positive side to our second pad on that F7140. So let's go back over the microscope. And remember, this pad up here is what's short of the ground. So we're going to solder this on right here. Let's add a little bit of flux just to make sure we get a good solid connection. Oh. Okay. Okay. And then we're going to solder the ground wire onto something like this, like a screw hole. Add a little bit of flux to this. And we're going to solder our ground wire onto it. Okay. Now, what we're going to do, let me get a better view for you here. Alright, so my power supply here, let's go ahead and turn that on. And how much voltage goes through PP bus? We're looking at 12.6 volts. Are we going to inject every bit of 12.6 volts right away? Well, let's not do that, but let's start off with something like 3 volts. Okay, or 2.9, 3 volts, somewhere around there. And so I'm going to go ahead and turn it off. Now that we have the power set, let's plug in our power, our wires. And what's going to happen is you're going to see this amperage be high. Yeah, we got 5 amps of power going through. So whatever is shorted on this board is going to start getting hot. So let's fill around. And it's warm up here, right where we replaced that chip. So let's go back under the microscope here. And let's add a little bit of alcohol to this chip and just see if this is what is causing the short to ground. Yeah. So you see that? So we still have a short to ground on this chip. And it's interesting that it is, because we checked all that, didn't we? And we checked all the rails there, all the pads, and there was no short to ground. So why is there a short to ground now? Okay, well, regardless, there is. So we're going to turn off my power supply, and we're just going to remove that chip now. See if we can figure out what's going on. Taking a look firsthand. Do you see anything? I don't see anything particularly. And it could be that this pad down here is ground. And so this is touching that pad and getting shorted out. Let's check and see with the multimeter. We're still in resistance mode. Is that ground? Why, yes it is. Okay. Well, that's no fun. So what we're gonna have to do is just cut this short. Let's cut it off like right in here. It looks like this ground goes all the way through, which makes it difficult. So what we're going to do is just pick this up a little bit here. Let's get an X-Acto knife. And let's just cut this back. Okay, let's measure our pads. Are we short at the ground? We're still short at the ground. Still short at the ground. So let's see. This is not short to the ground over here, so we're good here. But something on this rail here is short to the ground. What could it be? Let's remove this coil. Shorted the ground on both sides of this. We are here, and we're not here now, so this coil was carrying the short. Alright, so this chip was okay. we're okay on this chip. It's just something over here. Just toward the ground. Well, let's look on the board view. See what we can find. So we have this coil here on pin 1. PP3B3S5 is short at the ground. And boy, does that go to a lot of places. Alright, so 3B3. So we got 3.3 volts going through on this. Here's another thing we're going to try. We're going to try and inject 3.3 volts on this line and see what area gets hot there. So let's do that now. We'll go. We're going to solder. We're going to first of all remove these cables from this line here. And then we're going to solder it over here. Let's put this one here. And we'll put this one here. Alright, so now let's change our power here to 3.3 volts. We got it at, we had it at 3. Let's just keep it there. So let's plug the power cables back in. And we have 5 amps again. So we have, again, obviously a short on this rail. And now let's feel around and see if we can figure out where that short is coming from. I feel heat, but I don't feel where it's coming from. Okay, so the CPU is getting hot. Actually, something over here. Let's look at the board view. So we have these on that rail. Let's look under the microscope. Let's put a little alcohol in that area. Whoa, that's really hot. All right, let me remove the heat sink real quick. So this is what is boiling hot. As you can see. So unfortunately, let me go ahead and turn the power off to that. It looks like our CPU is bad, unfortunately. So, I mean, let's go back over to the board view real quick. Oops, I didn't mean to take it off that. Alright, so we have, we were looking at this line right here, and as you see, it goes to a pad underneath the CPU right here, which was getting boiling hot, and that's about in the exact area of the CPU that was boiling. So unfortunately, it looks like possibly the short to ground is because of the CPU. The CPU itself has the short in it, which is causing all these rails to be shorted to ground. So unfortunately, this is not going to be repairable. We don't have these CPUs on hand. We can't get them at a decent price to make this repair worth it. So unfortunately, we're going to have to tell this customer that it's not repairable, and we're going to have to move on with getting a replacement board for them. So this was a little bit longer video than what I wanted to do, but you can see my thought process of trying to figure this out. Hopefully you can anyways. It took a little time, but unfortunately in situations like this, it just ended up not being repairable. And like I said, the whole issue may have come from having a third-party battery. It's likely that this battery just output the wrong amount of power, could have caused a surge, and it's really not worth saving the money usually to buy a third-party battery for these machines, because you don't know how they're made or where they come from. So anyways, I hope you learned something with this video. It's disappointing that it wasn't repairable, but it is what it is, and we'll move on to the next repair. Hope you have a great day. We'll talk to you next time. And before I go, I'd like to say just one more thing about this. The repair process that I just did, the customer's paying nothing for this because it's not repairable. So there's no fix, there's no fee. And I just wanted to mention that to you guys. You know, it takes a lot of time to do this diagnosing. So when something's not repairable, unfortunately, we don't get paid for that. So we move on to the next board. Unless the customer, of course, wants to buy a replacement board, then of course they would want to. We would pay for that. They pay for that. However, for this process that I just did, the 45-minute process of narrowing down the issue just to be not repairable, we don't get paid for that. So just for you as a customer, so you know, we're not going to charge you for that. It's like we said, it's a free diagnosis. And if the customer just wants this board shipped back and not have to buy a replacement board, then all that we ask is that they cover the shipping cost. And I think that's a fair request for us to do. So anyways, if you're out there as a customer and you enjoyed this video, please leave a like. If you want to send your machine in for a repair, please do so. You can see our website, powerwithmeta.com. You can see it below, right below me there. And please let us know if you have anything else. Just you can give us a call as well. So anyways, hope you have a great day. We'll talk to you next time.